How do you solve math pattern questions quickly? Well, pattern questions can be really tricky when you have no clue where to start. But don't worry, in this video, we are going to teach you the secret behind pattern questions so that you can solve them in a flash. After going through this video, you can try out the questions at our website and see whether you have mastered the skills you need. Are you ready? Now here's a question on patterns. Thomas formed some figures with chocolate. Study the pattern. How many chocolates will he use in figure 8? Take a few seconds to think about this and see if you can figure it out. Now let's go through this together, alright? What was the first thing that went through your mind when you were looking at this problem? Yes, I know the chocolate looks really delicious, but I'm sure you were thinking hard about how to solve the question, correct? The first thing that we need to do in order to solve pattern questions is to look at it. So let's observe the shapes and see whether they are the same. If they are, great! That's one less thing to worry about. If they are not, we'll try to look at what's different. Okay? Next, when we're dealing with pattern questions, we'll need to look at the number of items and how they are arranged. Is there anything special about the way they are arranged? Compare each figure and look out for any changes. Let's use this question as an example. Alright? We can see that all the shapes are the same. So we are playing with little squares of chocolate. And looking at the items, there's one square in figure 1. And as we move on to the next figure, what do you notice? There seems to be an additional row of chocolate and it's made up of 3 chocolates. And moving on, we'll see another row of chocolate. And how many chocolates are there in this row? 5, correct? So what can we tell? We know that this pattern starts with one piece of chocolate. Then as the pattern number increases, so does the number of rows. And for those of you who have very sharp eyes, you notice that the pattern number and the number of rows are the same. So there's 1 row in figure 1, 2 rows in figure 2, and 3 rows in figure 3. Then what about the number of squares in each row? Every time we increase the row by 1, it looks like we'll add 2 more chocolates to the next row. So looking at this, 1 becomes 3 and 3 becomes 5. Do the numbers 1, 3 and 5 ring a bell? If you said they're odd numbers, that's a very good observation. After studying the figures, I'm sure all of you have a better idea on how the pattern works now, correct? But just to confirm that our guess is correct, let's try to sketch the pattern for the next figure and see whether it's true. In figure 4, we will have 4 rows. And since the chocolate in each row increases by 2, the number of chocolates in the 4th row will probably be 5 plus 2, which is 7. This looks right. But here's the golden question. If we were to solve the problem, are we going to keep drawing all the figures until we hit figure 8? I sure hope none of you said yes to that. Unless you have one eternity to do that, I'll suggest you use a faster and smarter method to solve this. And yep, you've got it right. We are going to use the power of math. To do that, we'll try to apply the rule that we came up with just now. Okay? So we know that the number of rows is always the same as the figure number. So since we are looking at figure 8, the number of rows must be 8, correct? In other words, we will have 8 numbers. Now, we know that the first row has 1 chocolate and the subsequent rows are made up of odd numbers after 1. So we are going to write all the numbers of the chocolate in each row until we have 8 numbers. So let's recite the odd numbers. We have 1, 3, 5, 7, 9, 11, 13, 15. So 8 numbers in all. Now that we have all the numbers that we need, we are going to add them up. Before you start adding 1 plus 3 plus 5 plus 7 plus so on, let's think about whether there's a better way to do that, okay? And this is a very important thing when we are solving math questions. Always look for the best way to solve things, just like in real life. And as it turns out, there is a method that we can use, and it's known as the rainbow method. For those of you who are not familiar with it, this is how it works. We are going to add the first and last number in the sequence, the second and last second number in the sequence, the third and last third number in the sequence, and see what happens? All of them add up to give us the same answer, correct? And that's 16. So the next thing that we are going to do is to look for the number of pairs of such numbers. Since we know that we are working with 8 numbers in all, this turns out to give us 4 nice pairs of 16. So instead of adding this whole string of numbers one by one, we can multiply 16 by 4 straight away. And this will give us 64. And that's our answer to the question. We have 64 chocolates in row 8.
Yay!
But some of you might be thinking, what if we need to find the number of chocolates that Thomas used for figure 9 instead? If we need to solve for that, you'll notice that we'll be dealing with 9 numbers now. And using the rainbow method, we'll pair up the numbers as before by choosing a number from the front and a number from the back. But as you can see, every pair adds up to 18. But because we have an odd number, there will be a middle number that's all alone. And we'll need to add that in as well. This is something that we need to take note of when we are dealing with odd figure numbers in this case. So far so good? But that's not the end of our video yet. We have reserved the best for last. And there's actually an even easier way to solve this pattern question. But it requires a bit more thinking. Now we are going to do something very exciting. We are going to reverse time now, and I'm going to show you some magic. Are you ready? So here we have the same pattern, but this time round, I'm going to move this square here over here. And I'm also going to move these squares here over here. Oh my gosh, I know, right? Can you figure out what's the shortcut to find the number of chocolates in each figure now? We have 1 square in figure 1, 4 squares in figure 2, and 9 squares in figure 3. Do you know how the number of chocolates are related to the figure number? If you are familiar with square numbers, you would have figured out that the number of chocolate in each figure is simply the square of the figure number, correct? And that's the beauty of math. So instead of going through the long process of trying to figure out how to find the number of chocolate in each figure, we now have an even better shortcut. And this sure beats drawing the figures one by one, correct? So if anyone asks you to find the number of chocolates in figure 101, or 999, or even 9999, you'll be able to solve it in a flash. Now that you have a better understanding on how to solve pattern questions, try out the pattern questions in Practical and see whether you have mastered the skills. Thank you for watching. Until next time, happy problem solving!